Global change processes, whether natural or man-made, affect the equilibrium of the system Earth, and with this, our lives and the lives of future generations. Many areas of the Earth's surface are vulnerable to natural hazards, such as earthquakes or tsunamis, which are caused by dynamic processes in the solid Earth, the atmosphere, and the hydrosphere. In addition, the effects of climate change, such as sea level rise and extreme weather events, are becoming increasingly threatening and pose a growing challenge to humanity. Geodesy is the science of determining the shape of the Earth, its gravity field, and its rotation, as well as their variations. Essential to modern geodesy are stable and consistent geodetic reference frames. These reference frames provide the fundamental layer for the determination of time-dependent coordinates of points or objects, and for describing the motion of the Earth in space. Reference frames enable consistent interpretation of global change processes and reliable monitoring of climate change impacts. GGOS, the Global Geodetic Observing System of the International Association of Geodesy, is a collaborative contribution of the global geodesy community to the observation and monitoring of the Earth system. GGOS works closely with the IAG services, as well as with the International Union of Geodesy and Geophysics, and other stakeholder organizations, such as the United Nations Committee of Experts on Global Geospatial Information Management and its Subcommittee on Geodesy. The work of GGOS includes a strong focus on geodetic observations. The observational toolbox of geodesy comprises different sensors and instruments on the Earth, in the air, and in space. When combined, these diverse infrastructural elements create one large, comprehensive geodetic instrument for monitoring the system Earth on a wide range of spatial and temporal scales, and with a high accuracy. The ground-based infrastructure consists of a worldwide distributed network of stations of different geodetic techniques. These include observations of extragalactic objects by VLBI to determine the orientation of the Earth in space, laser ranging to track satellites and the Moon, DORIS, one of the techniques for precise determination of satellite orbits, and finally, GNSS satellites for global navigation satellite systems, observations via a dense network of ground stations. Furthermore, geodetic space techniques on satellites are used for gravity measurements to detect the Earth's mass distribution and its changes, as well as observations of the Earth's surface, including oceans and ice sheets. These observation types are complemented by terrestrial measurements, such as gravity sensors on the Earth's surface that improve global knowledge of the Earth's gravity field, and tide gauge measurements to record the height of seawater relative to the coast. All of these geodetic observations are managed by the IAG services, the most essential part of GGOS. These services generate geodetic products relevant for geodesy, as well as many other scientific applications, such as the geodetic by collecting and analyzing the various and diverse geodetic observations. Accuracy and robustness of the products, quality control, timeliness, and state-of-the-art processing are the essential aspects of the IAG services. GGOS works together with these services to facilitate the generation of geodetic products and advocate their fundamental benefit to science and society. Geodetic products provided by IAG services include Earth orientation parameters, global and regional reference frames, satellite orbits, height systems, as well as the Earth's gravity field and its temporal variations. Geodesy provides important data and products for monitoring ice sheets and glacier variations, determining sea surface heights to monitor sea level changes, monitoring variations of station positions to determine tectonic plate motion and local land surface deformations. Geodesy enables the generation of digital elevation models as well as atmospheric products for better understanding the thermosphere, ionosphere, and lower neutral atmosphere. With this, GGOS endeavors to facilitate and enable production and sharing of the Earth observations needed to monitor, map, and understand changes in the Earth's shape, rotation, and mass distribution. Today's geodesy-informed decisions will determine the well-being of future generations. Therefore, GGOS seeks to promote informed, Earth observations-based decision-making. Please visit the GGOS website to learn more about the multifaceted world of geodesy and its ever-increasing benefits to science and society.